Exploring the work of Erwin Schrödinger, Quantum Mechanics Explained. Welcome back to our channel. Today, we're diving into the mind of Erwin Schrödinger, a visionary physicist whose work reshaped our understanding of the quantum world. From his revolutionary equation to the infamous Schrödinger's cat paradox, his ideas continue to spark curiosity and debate. How did a man who once called quantum mechanics nonsense become one of its most iconic figures? Let's simplify his contributions and explore their impact. In 1926, Schrödinger derived an equation that became the cornerstone of quantum mechanics, the Schrödinger equation. Think of it as the quantum version of Newton's laws. While Newton predicted the motion of planets, Schrödinger's equation describes how particles like electrons behave at the tiniest scales. Wave function. The equation calculates a wave function, a mathematical description of a quantum system, like an electron in an atom. This function doesn't tell us exactly where a particle is, but it gives probabilities of finding it in different states. Energy levels. For the hydrogen atom, the equation predicted exact energy levels, matching experimental data. This was a huge leap. It explained why atoms emit light at specific wavelengths and validated quantum theory. Schrödinger's work unified earlier ideas like Louis de Broglie's matter waves and showed how particles could behave as both waves and particles. The quantum paradox, Schrödinger's cat. In 1935, Schrödinger devised a thought experiment to critique the prevailing Copenhagen interpretation of quantum mechanics, which claimed particles exist in all possible states until observed. To highlight the absurdity, he imagined a cat in a sealed box with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, the Geiger counter triggers the poison, killing the cat. Until the box is opened, the cat is in a superposition, both alive and dead simultaneously. Why this matters? Measurement problem. The experiment questions when quantum superposition collapses into a single outcome. Is it when we observe it, or does nature decide earlier? Philosophical debate. Schrödinger's cat became a symbol of quantum weirdness, challenging our intuition about reality. Though meant to mock the Copenhagen view, the paradox became a cornerstone of quantum theory, inspiring interpretations like the many worlds theory, where every possibility exists in parallel universes. Legacy and impact. Nobel Prize, 1933, shared with Paul Dirac for the discovery of new productive forms of atomic theory. Quantum biology, later Schrödinger's book What is Life?, influenced DNA research by suggesting genes encode information in molecular structures. Cultural icon. The cat paradox permeates pop culture from TV shows, The Big Bang Theory, to memes, symbolizing uncertainty and curiosity. Ironically, Schrödinger himself disliked the probabilistic nature of quantum mechanics. He once grumbled about physicists using his equation for calculating their shitty matrix elements and preferred classical determinism. Yet his work became indispensable to modern physics, chemistry, and technology, from semiconductors to quantum computing. Erwin Schrödinger's brilliance lay in bridging abstract math with profound questions about reality. His equation unlocked the quantum realm, while his cat challenged us to rethink observation and existence. Thank you for watching. If you enjoyed this quantum journey, drop a comment below. Don't forget to like and subscribe for more.